Evaluating expressions and functions. These come up a lot in the exam, and you're given a function, you're given an expression, and you're told to plug in some values. So in this question here, we're saying evaluate the expression p squared plus 4q over 2 into q plus 1, and you're given values for p and q of 1 and 2. Well, what I do is I draw a box somewhere, and I sort of tidy it up, and I say p is 1, q is 2. And I work off that for all the various bits that follow. So I say p squared plus 4q is 2 into q plus 1. I've rewritten the equation. So I say, OK, p is 1, that's 1 squared, plus 4 times 2, that's the 2, is 2 into bracket, q is 2 plus 1. So I've now safely transferred the numbers across. Now I follow the rules of mathematics. I'll do the brackets there squared, and I'll make that 1 squared is 1, 4 times 2. And within the brackets, I have 2 plus 1. So those brackets then become 3, and then 1 plus 4 times 2 is 8 over 6. 9 over 6 is 1.5. So it's really just a process of being very slow, very methodical, and you'll pick up all the marks in that section. Second example, evaluate the expression a squared plus b plus c over 2 into b minus c. You're given this, where a is 1, b is 3, and c is 5. So again, I just draw the box. A is 1, b is 3, c is 5. And I go into lockdown mode. I rewrite the equation out, and I say, but a is, that's a 1 squared, b, that's a 3, and c, that's a 5. Then 2 into b, that's going to be the 3, minus the 5, and I've written it out. Then I go through the steps one by one, and I say 1 squared is 1, 3 is 3, and 5 is 5. On the bottom, in the brackets first, the double brackets, 3 minus 5 is minus 2. Double that is minus 4. 9 over minus 4 is minus 2.25. And that's that one done. Sometimes the question comes up in a different part of your program, and it says find the values or the value of a function for integer values between minus 5 and plus 5. So here's a quadratic equation, fx, or y is equal to x squared minus 2x minus 8. And you're asked now to plug in values for x. So you just write them out, sometimes in a table maybe, x squared minus 2x minus 8. And you start with minus 5. So everywhere you see x, you put in minus 5. Minus 5 squared, minus 2 times minus 5, minus 8. Minus 4 equals minus 4 squared, minus 2 times minus 4, minus 8. Minus 3 the next time is minus 3 squared, minus 2 times minus 3 is 8, and all the way down until f0. f0, 0 squared, minus 2 times 0, minus 8. Now you have to do the calculations on each of those. So in the first one, your minus 5 by minus 5 is 25. Minus by minus is plus. So 25 plus 10 minus 8. You do your calculations. 35 minus 8 is 27. Here, your minus 4 squared is your 16. Minus by minus is plus 8. Minus 8. They cancel. You're left with the 16. And all the way down to 0. And you get 0 minus 0 minus 8 is minus 8. On the next page, we just continue with the question because it said from minus 5 to plus 5. And we just plug in positive values of x. Here's f1. Everywhere we see an x, we put in 1. Minus 2 times 1. So in this case, it's 1 squared is 1. Minus 2 times 1 is 2. Because minus by plus is minus. Minus 8 is minus 8. All the way, minus 9. Down to 5. 5 squared is 25. Minus 2 times 5 is your minus 10, because minus by plus is minus. Minus the 8 is 7. So that's how we do it. And we do a lot of that on our course. We're given a function, and we're putting in values. It can also come up in another part of your course, where you're told, show that the point xy of 6, 16, where 6 is x and y is 16, satisfies this function here. So y is another word for fx, because really if you think about it, on your course, you really only have 2 dimensions. You've only got paper, pen and paper. We don't draw models. We don't bring in 3-dimensional structures. So we just really have x and y. And x is horizontal, y is vertical, and everything is really in this plane. So when they say f of x is equal to x squared minus 2x minus 8, we invariably write the x on this side. And this is our f of x. But we also use this for y. So y is really f of x, or y is g of x. If you have y, x, you'll have y, whether it's called fx or gx or something else. So here we've got this equation that said fx is this, and we're to see if it satisfies the point 6, 16. Well, remember that xy is 6, 16. So in sort of longhand, we're saying x is 6 and y is 16. X is always first in the alphabet. It comes before y. And we always think of horizontal before we think of vertical. When we're reading a book, we read horizontally, whether we're in a Western culture from left to right or from right to left, before we read vertically. So it's always, we always talk about x first and then y. So our coordinate system there is saying is this true that when x is 6, that y is 16? So we're now going to try f of 6. And that's really what we're doing here. We're saying, plugging in the number 6 into f of this. So f of 6 is 6 squared minus 2 times 6 minus 8. 36 minus 12 minus 8 turns out to be 16. And that's what we were asked to prove. So on this particular equation, xy, 6, 16, does satisfy the function. The point 16 will be on the graph. We weren't asked to draw the graph. We were just asked, does that point satisfy the function? And it does. It needn't always be a case where the point satisfies the function. Here's an example where they say, check whether or not the points x1, y1 of 2, 10 and 3, 5 actually satisfy the other function. So does 2, 10 or 3, 5 satisfy the function? Well, let's take the point 210 first. On the 210 case, we could say that in 210 we could say x1 is 2 and y1 is 10. Or x is 2 and y is 10 if we wanted to do that. And just plug in the numbers. So here we're saying x is 2. The function is gx. So gx is minus x minus 8. Everywhere we see an x, we're going to put in a 2. So instead of the x, we're going to have the 2. So minus 2 minus 8 turns out to be minus 10. So it looks like the point 2, when x is 2 and this is 10, 2 minus 10. So 2 minus 10 does not satisfy the function. Okay, so we'll make that 2 minus 10 there. That would satisfy the function. Now, let's look at the next point here. And we'll see if this point here, 3, 5, satisfies the function. 3, 5. When x is 3, gx is minus x minus that. Minus 3 minus 8 is minus 11. So this says that the point minus 3 minus 11 is on the graph. We wanted to see if point 3, 5 was on the graph. Is 3, 5 on the graph? No. 3 at minus 11 is. So this does not satisfy the function. This is not on the graph. Is that okay? Excuse me. Now, we turn now to example 6, and it's saying, okay, let's look at fx is a squared fx is x squared plus ax plus t, where these are members of R, the real number system. Now, find the value of the function given that f of minus 5 is f of minus 1. We are told that find the value of a given that f of minus 5 is f of minus 1. Now, what we're saying here is that this is the general function. X squared plus ax plus t is the general function, and we're told that f of minus 5 is f of minus 1. How would we find f of minus 5? Really what we're saying is that x is equal to minus 5. X is equal to minus 5. We just plug in minus 5 everywhere we see x. So let's do that. Everywhere we see x, we put in minus 5. Minus 5 squared plus a times minus 5 is t. 25 minus 5a plus t is f of minus 5. We're also told that that's equal to f of minus 1. So let's plug in minus 1. Everywhere we see an x, we put in minus 1. Minus 1 squared plus a times minus 1 is t. So that turns out to be 1 minus a plus t. And what were we told about those two? That they were the same. So if they are the same, then we are told that 1 minus a plus t is the same as this. Rewriting, we get 1 minus a plus t is the same as that. That's an equation. Can we simplify this in any way? Well, we could decide to bring the a's to the other side, or the t's to the other side, or whatever, or as we did before. But the first thing we might see is that there are t on both sides, and if we were to substitute the t on both sides, take the t from this side and take the t from that side, we would find that they cancel, and we would get that 1 minus a is 25 minus 5a. If we took the a's over to the other side, we'd get 4 a's on this side, and took the 1 to the other side, we'd get 24. If 4a is 24, what's a? We don't like the 4, we divide by 4, a is 6. So what we have found from that is that the function here that we were working from, that was basically, find it there in a sec, x squared plus ax plus t, we have found that the answer for a is 6. So the function we can now rewrite, instead of x squared plus ax plus t, we can write as x squared plus 6x plus t. That's f of x. And that's written here like this: x squared plus 6x plus t. Now, we're also told that if f1 is 8, we can find the value for t. Well, how do we do that? Well, we know now that the function is given by x squared plus 6x plus t. We're told that f1 is 8. So let's plug in 1 into x. Where there was x, we put in 1. Where there's x squared, we put in 1 squared plus 6x plus t. 1 plus 6 is, plus t is that. 7 plus t is that. T is 8 minus 7, which is 1. So what we have done in all of that is that we have found that they can ask a question with an equation with an unknown, not only x, but both a and t, give us some information, we do the algebra, they give us some hints, and we can solve it. And that's the end of that topic. Now, just before we start the next, you noticed that there was a mistake there, didn't you? That was my notes, okay? And we'll go back and fix that. Everything was fine if I just had the right note, which would be very good. You'll find that this will be changed in your notes. So I think it was on the minus 10. It was the 2 points, actually, that wherever they were. Which page was it? Sorry, it was slide 32, example 5. Check whether or not the point's this. If you change this to 2, comma, minus 10. Okay? That should have read 2 minus 10. It is correct. 2 minus 10 is correct there. It's just those 2 errors there. That should read 2 minus 10 and 2 minus 10. Is that okay? I'll fix that in the notes so that, but, anybody printing them down in future from the text, we'll just make that change. There's also a small thing. It probably came out okay, I think, on your book. There was a small thing there. This one here on slide 34, I don't know, did that or come through in your notes? Where AT is an element of or, it did? Yeah, it did, yeah. That's basically just I just have to get a photocopier. That's just on our photocopier here. Because those letters are sort of fancy for or and for C and for Q and all that sort of stuff, for the various number systems, they're not always on in the subset of all the letters that machines carry. It's in your notes because the PDF files are right, but it just got printed on a photocopier that didn't have it. That's the end of that, I think.